This is Unit 4, Similarity. Preview video 4.1, Ratios, Proportions, and Similarity. Don't forget the date, time, and location that you are watching this video. There are 4 things we aim to accomplish for this video. We're going to explain the difference between the concepts of ratio versus proportion. We're going to understand the impact that differing units have on ratios. We're going to define similarity and use to set up and solve proportions. We're going to be using shortcuts to similarity and solving proportions. So these are the 4 things we're going to do in about the next 15 to 20 minutes. First, we're going to explain the difference between a ratio and a proportion. Definition of a ratio. A ratio is a comparison of 2 values by division. It's a comparison of 2 values by division. You are surrounded by the use of ratios in your life. When you're working with units and ratios, especially centimeters, meters, feet, yards, you must get in the same unit before you can make a ratio. Please take a moment and find the units conversion page near the beginning of your reference booklet. You're going to need that for this lesson and all the lessons in this unit. Ratios. You need to be comfortable recognizing them these 4 ways. Words. A colon, 3 to 4. A fraction, 3 to 4. And a decimal, 3/4 of a dollar is 75 cents. So you need to understand that all fractions, all decimals are what we would call ratios. You need to recognize all 4 of them. Words, colon, fractions, decimals. A proportion is an equation of 2 ratios. So if all I have is a fraction, that's a ratio. If I have something like this, that whole thing is a proportion. So right here, I'm going to show you a little trick that the key to multiplying the key to multiplying is not multiplying. It's factoring. I'm going to show you how to use both of these without touching a calculator. It's an important skill. Ready? Very simple. The key to multiplying is not multiplying. It's factoring. So if I were to solve, this would be 15k equals 35 times 33. Vast majority of you, you'd be reaching for a calculator to multiply these out. I don't want you to do that. Watch carefully. You don't need to multiply. The key to multiplying is not multiplying. It's factoring. So I'm going to divide out that 15. Now let's take a really close look here. First, I'm going to factor out the 15 and the 35. I know 5 goes into both of those. 5 goes into 15 3 times. 5 goes into 35 7 times. Then I'm going to factor the 3. 3 goes into 33 11 times. So our final answer here is simply k equals 77. Look how easy that is without a calculator. Let's try that again. We're going to cross multiply. I have 2p equals 10 times 14. Do not grab a calculator. Instead, we're going to divide by 2. I can take the 2 either to the 10 or the 14. It doesn't matter. I'm just going to go this way. So p equals 70. It's a little trick. Key to multiplying is not multiplying. It's factoring. You need to understand the impact that differing units have on ratios. Definition of a ratio is a comparison of two values by division which are in the same unit. That's an important clarification. So let's do a couple examples together. I'd like you to put your finger right there, and I'd like you to read this aloud with me. Yes, aloud. Finger right where Trish is. Ready? Read out loud. Trish needed 3 feet of Velcro for every 2 yards of fabric purchased to make a table banner. What is the ratio of the Velcro needed compared to the amount of fabric? So this is what most students do. They see the 3, they see the 2, and they're like, it's a 3-to-2 ratio of Velcro to fabric. And they're like, ta-da, I'm done. No, you're not. Because your units here is 3 feet of Velcro to 2 yards of fabric. They're not in the same unit, so before you can make a final ratio, you have to get in the same unit. You need to know the conversion that in the first dimension, which is length, 1 yard is 3 feet. Therefore, 2 yards, 3 feet, is going to be a total of 6 feet. So the actual Velcro to fabric ratio is going to be 1 to 2 because you got in the same unit and then you reduce. So you would express the ratio is 1 to 2 of Velcro to fabric. Let's do this again. An industrial size recipe to make 300 chocolate chip cookies calls for 800 grams of sugar for 2.5 kilos of flour. What is the ratio of sugar to flour? Once again, the most common mistake is that we simply take the numbers 800 to 2.5 and we call it done. But that would be wrong. Just like it was wrong up here, it is wrong down here. Okay, you have to get in the same unit. So we have 800 grams to 2.5 kilograms. And this is of sugar to flour. You have to get in the same unit. You need to be familiar. Kilo means 1,000. So this actual ratio is 800 grams. And then 2.5 times 1,000 means I simply take that decimal and I move it over 1, 2, 3. So it's going to be 2,500 grams. Now that we're in the same unit, we can reduce. 2 zeros here, 2 zeros here. I have 8 to 25, and that is as far as we can go. So the ratio of sugar to flour in this scenario is 8 to 25. I want you to actually pause this video and do this page on your own. Restart as soon as you're done. Pause. Welcome back. Let's see how you did. You only had one problem. Now, if all you wrote was 44 to 2 and then you reduced and went like this, 22 to 1, that would be incorrect. The correct here is 44 centimeters to 2 meters. The first thing you had to do was to convert meters to centimeters, which if you use your units page, that's 44 cm to 200 cm. Now that you have the same unit, now you can reduce. 4 goes in there 11 times. 4 goes in there 50 times. So your actual correct ratio in this case is 11 to 50. You're going to be using ratios and proportions for the concept of similarity. We're going to define similarity and use it to set up and solve proportions. This, by far, is the most important skill of this video. First off, let's define what is similarity. You're actually very familiar with this concept. Similarity is things that have the same shape, but a different size. Same shape, different size. Whenever you go shopping for clothing, and the clothing comes in small, medium, and large, the shirts are the same shape, but they're coming in different sizes. We would call those shirts similar. Similar, and we use this little symbol here, it means similar. Same shape, different size. Same shape, different size. That's kind of the simplistic definition of similarity. Here's the mathematical definition of similarity. I call this SCARE. Similar shapes have congruent angles and ratios which are equal. Similar shapes have congruent angles and ratios which are equal. Let me explain. So here in these two shapes, you can see that the corresponding angles are congruent all the way through. So check, we have congruent angles. Now let's check our ratios. 4 to 24. That is a 1 to 6 ratio. 8 to 48. That is a 1:6 ratio. And you go all the way around and you check, and you can see, although the side lengths are not the same, the ratio is equal all the way around. So we would call these shapes similar. Same shape, different size. When we're dealing with similar shapes, once you establish similar shapes, you need to know the term called scale factor. Scale factor is the ratio of the sides simplified. The ratio of the sides simplified. And we use it as a fraction or a colon. For example, here's how I can establish. If I tell you that these shapes are similar, we're going to find the scale factor. So we're going to match short, short, and then here we go, medium, medium. And we check. If I tell they're similar, 10 to 15, 5 goes in here twice, 5 goes in here 3 times, 7 goes in here twice, 7 goes in here 3 times. So in these shapes, if I'm told they're similar, we would say the scale factor is either 2/3 left to right or 2/3 left to right. I'm going to do a couple sample problems, and then you're going to try a couple on your own. First, we're going to determine if the shapes are similar using scale. We're going to check the angles. We have 2 congruent base angles here that match, and 2 congruent base angles here that match. So we have congruent angles. Now let's check our ratio. Short to short. 6 goes in there 5 times, 6 goes in there 6 times. Let's try this. Edge to edge. 3 goes in there 5 times, 3 goes in there 6 times. Let's go long to long. 8 goes in there 5 times, 8 goes in there 6 times. And this matches over here, so again, that's a 5 to 6. So you can see the ratio all the way around is 5 to 6. So we would say check, yes, these shapes are similar. Once you know shapes are similar, you can use proportions, because if you have ratios which are equal, then the sides are proportional, and you can use them to solve for unknown lengths. Let me give you an example. It says the images below are similar, so you're not testing for similarity, you're using similarity. And we're going to solve for the unknown. But first, you have to match and mirror. Match the sides, mirror the direction. So this is where color coding comes in happy. So we have 2 short sides. We're going to match them up here, 2 short sides. Then we have a medium side and a medium side. And then you have the longest and the longest here. That's what it means to match. Now I'm going to make a proportion. All I have to do is mirror my direction. I'm going to give you 2 different versions so that you can see I can do 2 different versions. I can work in the same shape. So, for example, I can go like this. Blue to green. So I'm going from medium to long side. 36 to 42. Then I just have to match the same direction for the other side, blue to green, is the same as 6 is to unknown. That's within one shape. Or I can go from shape to shape, which is my general preference, and I usually work left to right. So I can go 24 to 4. And then I'm going to go like this, 42 to unknown. Either way, when you cross multiply, you're going to get the same thing. Now, I can reduce on the same side before I cross multiply. So here, watch carefully, I'm going to cross multiply. I have 4 times x. Whoops, nope. It's not 4 times x. That is 24 times x. Equals 4 times 42. The key to multiplying is not multiplying, it's factoring. Let me show you what I mean. I'm going to divide by 24. So I'm going to reduce what I can reduce. I can reduce 4 into 24. That's 1 and 6. Then I can reduce 6 into 42. And I get 7. So I get here x equals 7. Another way I could have done this is you can reduce on one side of a proportion to start with. For example, 4 goes into 24 6 times. Then I cross multiply, so I get 6x equals 42. And you solve, and I get x equals 7. Either way, you get the same answer. Or, rather than giving you the side lengths, you're actually given the scale factor, which is the ratio of the sides. So here, we're going to find the variable knowing the shapes are similar. Watch very carefully. The scale factor from A to B. That's the order that that's being done in. Watch very carefully. Let me color code that for you. A and B. So we're forcing to go from A to B. Our ratio is going to be 3 to 5. And if I want to complete that, I have to match, and I'm being forced to go right to left. Notice the order there. So this is going to be 2x plus 10 over 40. The only reason I can set up a proportion is I'm told we're similar to begin with. Cross multiply. So I get 3 times 40 equals 5, 2x plus 10. At this point, you are welcome to distribute and multiply if you choose to. However, I'm going to use a shortcut by dividing out that 5 without distributing. And then I'm going to take that 5 into the 40 and get 8. So on the left-hand side, I have 24 equals 2x plus 10. We're going to solve here. What's really nice about these problems, it's super easy to check if you're correct. So we're going to go ahead and put 7 right there. So 2 times 7 is 14, plus 10 makes us 24. Let's check our ratio here. 24 to 40. 8, good. So 24 to 40. 8 goes into 24 3 times. 8 goes into 45 times. Ta-da! You know you're right. Pause the video and do these 3 problems on your own. Welcome back. Let's see how you did here. So we're going to determine if they're similar by scale. So let's check. So look at the parallel lines. Match these with this parallel lines. So we're going to check our ratios here. 30 to 36. 6 goes in there 5 times. 6 goes in there 6 times. And then the short to short. 5 goes in there 5 times. 5 goes in here 6 times. The angles match. And so, yes, they are similar. Down here, given that they were similar, we match the sides up. So short goes with short. Medium goes with medium. Long goes with long. I'm going to make a proportion. You could have chose either the 15 or 24. It really didn't matter. I'm going to go short to short. So I'm going to go 15 to 20 equals 30 to unknown. Cross multiply. 15x equals 20 times 30. Divide this out. 5 goes in there 4 times. 5 goes in there 3 times. 3 goes into 30 10 times. So x equals 40. Here, your ratio from A, notice the order, to B. So we're going this way, is 3 to 7. So 3 to 7 equals, keep the color straight here, 3 to 7 equals 36 over 3x plus 27. Cross multiply, you get with 3 parentheses 3x plus 27 equals 7 times 36. Do you want to distribute the 3? Be my guest. You want to multiply 3 and 36 out, or 7 and 36? That's fine, but instead I'm going to take a shortcut and divide that 3 out. 3 goes in there 12 times, so I have 3x plus 27 equals 84. Minus 27 so I have 3x equals 57. I divide by 3 and I get x equals 19. The last skill is to know shortcuts to similarity. Now remember, we had shortcuts to congruency. If we have a set of angles or sides is minimally true, the triangles are congruent, which is same shape, same size. And we had 3 for congruency shortcuts: side, 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 angle, side, angle, side, angle, and angle, angle, side. These gave us triangles which were the same shape and the same size. Similarity shortcuts, we're going to use shortcuts till similarity for solving proportions. If something is minimally true, then the triangles are similar, not congruent, similar, which is same shape, different size. And there are 3 shortcuts to similarity that you need to be familiar with. First one is if you have 2 angles congruent, then the triangles are similar. Let me give you an example here. If you have 2 different colors, that's a wise choice right now. Let's trace this triangle, pull it apart. See in this diagram, they both share this angle right here. They share that, so that's congruent. So hatch mark, angle. And they both have 59 degrees right there. So we can say these triangles are similar by angle similarity. Remember, similarity is not congruency. Same shape, different size. That's angle similarity. Then we have if 3 side ratios are equal, then the triangles are similar. Notice I didn't say the sides are equal, the ratios are equal. Watch what I mean. We're going to go short to short. Ready? Here, short side to short side. Reduce. Seven goes in there 3 times. 7 goes in there 5. Let's go over here. Let's go medium side, medium side. Nine goes in there 3 times. 9 goes in there 5 times. Long side, long side. 13 goes in there 3 times. 13 goes in there 5 times. Notice the side ratios are equal. The ratios are equal, which means the triangles are similar. That's called side similarity. You have to add that little squiggle to it. Last one says this. If you have equal ratios, congruent angles, and equal ratios again, then the triangles are similar. This is called side similarity. Let me show you what I mean. Ready? We're going to match on the left. Short side to short side. 12 goes into 48 4 times. Longer side, longer side. 14 goes into 56 4 times. Then we have a pair of congruent angles. So here I have a pair of congruent angles, side ratios, and side ratios that are equal. That is called side similarity.